Hello everybody. So today we're going to be going over relative frequency histograms. Okay, it's section 4.3.1. All right. A relative frequency histogram is very similar to a regular histogram, except it changes your the bars in the histogram to have probabilities with them and percentages rather than just data points. Okay. So it kind of makes solving and using those bars a little bit easier, right? Because you've already changed them into percentages or data points or whatever. Okay, cool. So our first problem deals with these hats that this company is making. And they collect a sample of head circumferences for different women that are running this marathon, or not marathon. Oh yeah, it is marathon. And so they collected data from 40 different women, okay? And then the data is in your textbooks. Hopefully you're following along there. There's also an e-tool that I want you to open up, okay? So open up that e-tool because we're going to be using that, okay? So part A for number 61 asks about the mean, head circumference, and standard deviation, okay? So we want the mean, and we want standard deviation. I'm going to call it S. Remember, if you guys remember that. S stands for sample standard deviation because this is a sample of women that is running the race, right? So we're not going to use population. We're not going to use sigma. We're going to use S. Okay. So hopefully you opened up the e-tool. Down in the e-tool, if you scroll all the way down to the bottom, there's a button that says single variable statistics. Okay, if you click on single variable statistics, then it actually brings up your mean, and there's a 5-number summary there. How many data points you had, that's N, and then S and sigma down on the bottom, that's sample standard deviation and population standard deviation. So it gives us the mean. The mean is 53.3325. And then our S value is 1.1192. Okay, so there's our mean and our standard deviation. Awesome. Okay, that's part A. Part B, it wants us to make a histogram of the distribution of women's head circumference and sketch it. Use an interval from 50 centimeters to 57 centimeters with a bin width of 1. Okay, so we have our x-axis. We're going to start at 50, 51, 52, 53, 54, 55, 56, 57. Okay. And then if we go to our e-tool that we opened up, okay, you should have your histogram here. Okay. It starts at 51 and goes to 52, and that looks like it has a height of 5. One of our bars is really tall, so that's why I'm going to make the other ones kind of short. From 52 to 53, it looks like it's about 9. From 53 to 54, that one's at about 17. Yeah, go ahead. From 54 to 55, it looks like it's about 4. And from 55 to 56, it's 5 again. Okay, and make sure these add up. I think these do. 5 and 9 is 14, plus 17 is 31, plus, yeah, it's 40. Okay, so there's our histogram. Okay, and our e-tool does that for us beautifully. This data representation is really helpful, obviously, right? You can type in your values in there. You can sort your values if you wanted to, like with a little wrench there on your e-tool. Okay, if you just sort the list, it puts it from lowest to highest, so you can actually, figure stuff out on your own if you wanted to make your histogram by yourself and so on. Okay. All right, so that was part B. That was our histogram. Part C, it says hat size is determined by the whole number portion of a woman's head circumference. For example, a woman with a head measuring 55.8 centimeters would need a size 55 hat. According to your histogram, how many women in the sample need a size 52 hat? Okay, so size 52 hat would be all the women from 52 to 53, right? 52 to 53. So it would be this bar right here. Okay? Because if they're like 52.3 centimeters, right, then it gets brought down to a size 52 hat. Okay? So, there we go. Okay. Size 52 hat. Yes. Okay. And we're not doing percentages, so just 9 women. 9 women need a size 52 hat. Okay? Perfect. All right. Then our last question for part A. It says, what percentage of the women in this sample have a hat size less than 54? Okay, so a hat size less than 54. Remember, 54 starts here, and 54 would be like the 4, right? And so a hat size of less than 54 would actually be these 3 values, 17, 9, and 15. Okay, so part D, hat size less than 54, okay, there would be 5 plus 9 plus 17 women have a hat size less than 54. So that would be 31 over 40, which is 77.5%. Okay. So 77.5% of the women in this sample have a hat size less than 54. Okay. Cool. So that's our histogram. That's how we kind of use our data from this histogram. Okay. And then number 62 is where we start changing this histogram to be a relative frequency histogram. Okay. And so kind of like what we did in part D here, I'm going to take this information and then I'm going to divide each of these bars. So like this 5, I'm going to do 5 divided by 40. Okay, 5 divided by 40 is 0.125. Okay. 9 divided by 40 would be 0.225. 17 divided by 40 would be 0.425. 4 divided by 40, that one's easy, that's 0.1. And then 5 divided by 40 again is 0.125. Okay? Cool? Cool. So then, that's how we changed it into a relative frequency histogram. So that was 462 part A. Okay, is all of these probability values, and I put those right at the top of each of those bars because that represents like how much of the data is in that bar, right? So in this first one, there's 12.5% of our data from 51 to 52. Okay. Cool. Then part C from 462. Okay, part C. It's asking relative frequency histograms make percentages easier to visualize. Use the histogram to compute the percentage of hats in the sample between size 52 and 55. Okay, so between size 52 and 55. Okay. So size 52 and 55. Well, 55 remember it has this value in it, right? If we have the hat size of 55. Okay, so for part C, we're adding almost all of them together, right? we have 0.225 plus 0.425 plus 0.1 plus 0.125. Okay, if we add all those together, that is our percentage of hats between size 52 and 55. Okay, if we add these together, I believe we get 0.875. Okay, or 87.5%. Okay, so 87.5% of the women in the sample have hat sizes between 52 and 55. Okay. Then lastly, part D. Okay, part D is asking for what percentage of hats in the sample are below size 56. So we want below size 56 now. And size 56, well, there's nobody in size 56 hat, right? So everybody below that is counted. Now we already have 87.5%, so all we have left to do is add this guy for part D, right? So 0.875 plus 0.125. And if you add those together, we actually get 1, which is 100%. Okay? So 100% of our hats in this sample are below size 56, which makes sense because that's all of our data, right? Okay? Which is why it's 100%. All right. That's pretty much, there's one more problem in this section, but I think we're good with this, as long as you guys understand this. Again, you can listen to this again if you need some extra help. But relative frequency histograms, again, basically just take the original histogram and then make probabilities for each of those bars. Okay? So there we go. There's a learning log in this section. Okay, so if you go to 4-64, our learning log, it's on relative frequency histograms, right? So talk about what we did in this lesson. Oh, missed frequency. Okay, relative frequency histograms. Okay, and then we also have a math notes in this section, and the math notes talks about symbols for the standard deviation and the mean. Okay, so if we're talking about a population, first it starts with n. N is the number of values in a data set. Okay, so n, number of values in a data set. Okay. So on that last one, our n would have been 40, right? Because we had 40 hat size samples. Okay. When we talk about the population, we use this thing is called mu, and it stands for the mean. And then we also have sigma, right? And that stands for standard deviation. Okay, and so that's our population. When we are talking about a population of things, we use mu and sigma. Okay, those are both Greek symbols. When we're talking about a sample, now, we already know one of those, but our mean for our sample is called x bar. Like, we literally just call it x bar. I don't know why. But that's our mean for our sample. And then we also have S, which is just S. And that's our sample standard deviation. Okay. So this chapter has a lot of stats in it. And we'll get to more stats later. So these things are important, right? N is the number of values in our data set, right? when we're talking about a population, the mean is mu, and the standard deviation is sigma. And then when we're talking about a sample, the mean is x bar, and S is our standard deviation. Okay? All right. Well, thanks for listening. I appreciate it. And enjoy your day.